Algebra 1, Final Exam Guided Review 2. We're just going to do numbers 4 and 5 in this one. So this is numbers 4 through 5. All right, so first number 4. It is solve by factoring again. Solve by factoring. If you can't tell yet, there's a decent amount of this on our guided review. And yeah, so you can expect there to be multiple problems on the final exam that are along the line of quadratic equations, so equations with an x squared, and solving them by factoring them and factoring them. So you might have some that is just factor, some that is solve. And if it's just factor, there's no equal sign, and you are, so if I like rewind to number 3, if you pretended that this equals 20, oh, not that equals 27. If you pretended that you started with out that equals 0 and you just started with this, and the instructions were factor, then your final answer would be this. That is factored. Then if there's solve, then you have equals, and you have that equals 0 hanging out there, and then you set each factor equal to 0, and then you get what x equals. All right, so just keep in mind that difference between solving and factoring. Okay, back to number 4, though. Here's what we're solving by factoring. We are solving 2x squared plus 9x plus 9 equals 0. Now, key difference between number 4 and number 3. Number 3, if I scroll up, we had a 1x squared. Number 4, we do not have a 1x squared. And that changes how we have to do it. When it is not a 1x squared, we need to find a times c. In this case, it is 2 times 9, or 18. And then look for two numbers that multiply to equal whatever a times c is, and add to equal whatever b is. And then split bx into two terms using the numbers from step 2. I'm going to circle these. I usually like to circle steps. And then finally, factor by grouping. Okay, so we already did step 1. We found that 2 times 9, so a times c. 2 times 9 is 18. So now we need to take our 18, so our step 2 now. And we need to take our 18, and we need to look for two numbers that multiply to be 18 and add to be b. b is 9. Well, 18 is 6 times 3. My mind went first to 9 times 2, but 9 times 2 adds up to be 11, not 9, so 6 times 3. So now I can use this 6 and this 3 to do step 3, which is split my bx terms, so split that 9x into a 6x and a 3x. So that looks like this. So I'm going to rewrite my whole equation. 2x squared, instead of plus 9x, I'm going to do plus 6x plus 3x. Note 6x and 3x combine to be a 9x. So I haven't really changed what I'm dealing with. I've just changed what it looks like. And then plus 9 equals 0. Now I can do my factor by grouping. So factor by grouping, I'm going to take the first two terms, see what they have in common. They have a 2x in common. So I'm going to factor out a 2x. And I get 2x times, when I factor a 2x out of the first term, I'm left with just an x. When I factor a 2x out of the second term, I'm left with just a plus 3. And then what do my last two terms have in common? They have a 3 in common. So plus 3 times x plus 3 is what I'm left with, and I still have this equals 0. So now I see, ooh, I have an x plus 3 and an x plus 3. Let me factor out an x plus 3. What am I left with from the first big chunk? 2x. What am I left with from the second big chunk? Plus 3. I still have equals 0. Now I have a factor, x plus 3, times a factor, 2x plus 3, equals 0. So I can set each factor equal to 0 and solve. So I'm going to say x plus 3 equals 0, or 2x plus 3 equals 0. This one, subtract 3 from both sides. I just get x equals negative 3. This one, I subtract 3 from both sides. I get 2x equals negative 3. Divide both sides by 2. So I get x equals negative 3 halves. And that is my solution. That if I plug those back into the original equation, they would make the equation true. All right, that's number 4. Number 5. I'll go on to the next page. Number 5, solve by factoring. And here's what we have. We have 36x squared equals 121. So again, to solve by factoring, I need equals 0, so I'm going to subtract 121 from both sides. That will give me 36x squared minus 121 equals 0. Now I'm like, ugh, I have 36x squared minus 121. Well, you could view this as 36x squared plus 0x minus 121 equals 0. And you could treat this just like a number 4 problem and do a times c. 36 times negative 121 is going to give you negative 4,356. And then you could look for two numbers that multiply to be negative 4,356 and add to be 0. But I don't want to do that. And instead, I recognize, oh, this is something squared minus something squared. When I have something squared, or when I have a term minus a term, I can always factor that to be the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So what's the square root of my first term? 6x. What's the square root of 121? 11. Square root of the first term, 6x. Square root of 121, 11. So I get 6x plus 11 times 6x minus 11 equals 0. So again, take each factor, set equal to 0. So I have 6x plus 11 equals 0, or 6x minus 11 equals 0. So this one becomes 6x equals negative 11. So therefore, x equals negative 11/6. And this one becomes 6x equals a positive 11. So x equals a positive 11/6. And that is the solution. So what was going on here was a difference of squares and factoring a difference of squares in order to solve. Okay, that is numbers 4 and 5.